So our problem here is that we have three objects, A, B, and C, and we're going to try to find the total gravitational attraction on B. Now, when we consider that, you have to remember that they're going to be affected differently, right? I've got three different masses, different distance between them, but I'm trying to think of what is the overall effect on the middle one. So I want to consider that. So when I think about what A is doing, A is trying to pull B this way. And then if we look at C, it's trying to pull B this way. And this one is more massive and closer. So obviously this one is going to win. So I'm going to consider this the positive direction because this is going to be the kind of winning direction. I can see that just by assuming. Now, if it was harder to guess because maybe this one was bigger, but this one was closer, and you're like, I don't know which one. It doesn't matter. The number would be positive if it ends up going to the right. And if we got a negative number, then we know it's going to the left. So we can assume the direction based on whether we get a positive or a negative answer at the end. So I know in this case, I'm going to get a positive number if I consider this as my positive. So now I have to consider my equation. So when I do the math, I'm going to have two forces of gravity. So this is going to be my overall, right? What's going to happen to B, because it's going to be based on, so the force of gravity on B is based on the force of gravity because of C minus the force of gravity because of A, right? That's basically this force of gravity and this force of gravity. I've made this positive, or the right positive and the left negative. So when I go to put my numbers in, I'm going to find the force of gravity on B, the overall force on B. And I need to now change this into the equation. So remember, it's going to be the gravitational constant, the mass of, and in this case, I'm talking about B and C, divided by the radius, or the distance between B and C squared, minus this one, which is A and B. It doesn't matter which is which, right? Divided by the radius of A, B, the distance between A and B squared. So let's put all our numbers in. So our force will end up being 6.67 times 10 to the negative 11 times. I've got the mass of our first one, so 4.0 times 10 to the 24, and then our other one, 9.0 times 10 to the 24, divided by the distance between them, which is 3.0 times 10 to the 9, I think it was. Let's check. I've forgotten. Yeah, 3.0 times 10 to the 9, and then subtract. So I hope I can fit this. We'll write small, 6.67 times 10 to the negative 11, and then 2.0 times 10 to the 24. That's a 4. And then 9.0 times 10 to the 24, all divided the distance between them, which I believe was 5 times 10 to the 9. Yeah, 5.0 times 10 to the 9 all squared. So this is going to be good fun to put in your calculator. You can put it all in at once and get one answer. That's totally cool. I'm going to write down the two numbers I got just so that when you're doing this math and you see numbers in your calculator that you're like, yeah, I was doing okay, right? Just for comparison. But of course, this is not a step you would do. And in fact, if I was solving this myself, I would not write these numbers down. I would just write down my final answer, because I would put the whole thing in. But I'm pretty calculator confident at this point of my life. So I kind of just put big giant things in because I can. So my final answer that I got was I can only keep 2 digits, and that's because of these, right? So these are all 2 digits. So I'm going to keep 2 sig figs. So 2.2 times 10 to the 20 newtons. Now, when I'm writing my therefore sentence in this case, I'm going to interpret this because there is a bit of interpretation because I picked the negative and the positive. So in my therefore sentence, I would say, therefore, the overall force of gravity on object B is 2.2 times 10 to the power of 20, and I'll fix that in a second, newtons towards object C, because I need to give it a direction. Now you'll notice I didn't say to the right, I said towards object C, and that's because once we start doing with things with planets and things like that, you can't really say that this is the right and this is the left, right? Like, because if we're in space, then that's just based on my frame of reference, right? I could be on the other side of the planets and it would be still towards C, but then it would be towards my left if it was on the other side of those planets. So by saying it's towards object C, I'm giving a general interpretation that cannot be confusing.